This first video on projectile motion is about the x and y components of a vector, and the goal of this is to teach students how to break a vector up into its x and y components, as well as combine x and y vectors into the true vector for velocity or acceleration or force or whatever it may be. So if you think about the good old song from Offspring, Keep 'em Separated, that's the whole idea of this. The x values need to stay separated from the y, and the y values need to stay separated from the x. You can even think of it as the saying, what happens in Vegas stays in Vegas. And it's the same thing with the x direction. What happens in the x direction stays in the x. What happens in the y direction stays in the y. So if you have a velocity that's x direction only, you can only use that velocity in a problem or equation to solve it. If your acceleration is x only, your positions are x only. And the same thing goes for the y. Now you may be thinking, I've never said I'm going 30 miles an hour north and 65 miles an hour east. And of course you haven't. That doesn't even make sense. So, what do we do in a situation like this? You're going to combine the x and y, and you're going to use Pythagorean's theorem and trigonometry to do so. So for example, we have in this problem something's traveling 20 meters per second in the y direction and 13 meters per second in the x. So the question is, how fast is it going? We use Pythagorean's theorem, v squared equals 13 squared plus 20 squared, and solve for v. We get 22.85. That means the velocity is 22.85 meters per second. Now velocity has direction, so we need the angle. We're going to use SOHCAHTOA. Since I know the adjacent, the hypotenuse, and the opposite sides, I could use sine, cosine, or tangent. And this one I've chosen to use tangent. The tangent of theta will equal the opposite, 20, over the adjacent, 13. And my angle turns out to be 56.98 degrees. So the final answer is the object's moving with a velocity of 22.85 meters per second at 56.98 degrees above the positive x-axis. Here's another example, and in this case we're going to go the other way, where we're given the initial vector and we need to break it up into x and y components in order to solve important aspects of a situation, such as how high did the punt go, how far did it go, and things like that. So a punter kicks a ball at a 65-degree angle with a velocity of 33 meters per second. In order to do this, we're going to have to use SOHCAHTOA and break everything up into x and y. For the x direction, I'm going to use the cosine. So cosine of 65 is Vx over 33. That means if we move 33 to the other side of the equation, 33 cosine 65 is Vx, or Vx is 13.9 meters per second. Vy, we're going to use sine. So sine of 65 equals Vy over 33. We move the 33 over, and we solve it out, and you get 29.9 meters per second. So what this is saying is the velocity in the x direction is 13.9 meters per second. So if I'd like to ask a question, how far does the ball go? I need to use, since that's an x direction question, I need to use the x velocity of 13.9. If I'm concerned about how high does the ball go, I'm going to need to use the y direction velocity of 29.9. Thank you for watching.